Where'd it go? Oh, here they are. Oh, I have it copied from earlier. Sweet. Okay, I'll just put these here. Nice. Yeah, give these a try, these 6 questions. Convert them from one form to the other. And I will log base 12 of 144 equals 2. So go ahead and take some time to attempt these 6. And notice I didn't really mention, but hopefully I've drawn it well enough. The base is below the log, and the other number is in line with the log. It's not like this other number is an exponent of a. In other words, you're taking the log of c base a, if that makes sense.
So how do you like plug that in a calculator?
Yeah, that's a good question. We're going to get to that, just not today. But yes, you do need calculators for this. Like, if you want to know what the log of 3 is,
Okay.
you need a calculator, for sure. There are ways to estimate, but yeah, we're going to get to calculator eventually. We're going to learn how to navigate them first. Good question. And let me know when y'all finish, and we can go over these answers. Do y'all need more time, or are most of you done?
I'm done.
Let me know if you need more time, or I'm just going to go ahead and go to these. Alright, so 5 cubed equals 125. This would be log base 5 of 125 equals 3. 2 is 2 to the power of 3 equals x. 3 is log base x of 7 equals 5. 4 is y squared equals 5. 5 is 10 squared equals 100. And 6 is log base 3 of q equals 7. Any questions on these, y'all? It's kind of weird right now, but they'll get a lot easier to convert. Cool. Okay, let's also talk about the properties of these guys.
The heart thing was helpful.
Yeah, the heart thing, students like that. They do for sure. So there are, I guess, 3.5 properties that we're going to go over. So we'll talk about the first one. If you have the logarithm and I'll just leave the base undetermined. If you have the logarithm of a product, this can be split up. So this becomes, instead of log base b of x times y, this becomes log base b of x plus log base b of y. So a log of products turns into the log to the sum of the logs, if that makes sense. So this product turns out as a sum. Conversely, if you have a log of a quotient, well, what's the opposite of a sum? It must be subtraction. You get log base b of x minus log base b of y. So product turns out as a sum, quotient turns out as a difference. We also have, if you have log base b of, let's make sure this b is a little better, of x to the y power. So this is a little different now. The x is to the y power. This is equivalent to the y comes out front as multiplication. You get y times log base b of x. So exponents come out front as multiplication. So our third rule. I want to mention a couple more things. If you have, if it just says log, the base is assumed to be 10. The base is not written, it is assumed to be 10. And furthermore, there's another type of special log that's ln. This is natural log. So natural log is equivalent to log base e. And then lastly, imagine if we have log base a of a. So the base and what you're actually taking the log of match. Well, quickly, before I explain what happens here, let's set this equal to x and convert. So a to the x equals a. Well, x must be 1, right? So if you have a log and the base matches what you're taking the log of, the answer is always 1. If these two numbers match, the answer is always 1. And one last thing, let's imagine log of 0. Let's say this has a value. So remember, if the base is not specified, that means base 10. So this is base 10. If I want to convert this, this is 10 to the x equals 0. 10 raised to what power equals 0? Well, it's not 0, because 10 to the 0 is 1, right? There's no solution here. This has no solution. So log 0 is illegal. Can't do it.
Is the 0 like below the log or no?
This is log base 10 of 0. Or anything. Any base log of 0 is illegal.
Will you explain property 3 again?
Yeah. If you have the log base b of some number to an exponent, the exponent comes out front as multiplication. So I can do another example here. If you have log base 3 of p to the 5th, this becomes 5 log base 3. That is the ugliest G I've seen in my life. 5 log base 3 of p. Does this make sense?
Yeah, so you never have to like put the multiplication signs, I guess. You can just attach it all.
Right, yeah. When numbers are next to each other, it implies multiplication, right? I just put this there to be explicit, right? Alright, let's apply
So
some of these.
every single log has a base thing of 10, really, right? Has an understood 10.
So this is log base 3, right? And b can be any number. It can be any kind of base. But if the base is not written, it is assumed to be base 10. Does that make sense?
Season.
You say C, as in yes?
C.
Okay, wonderful. Alright, let's put some of these to work. So the idea here is that we will expand fully. Log base 3 of 2xy. So we have a product of three numbers. When you have a product on the inside, that's going to turn out as a sum when we expand them. This becomes log base 3 of 2 plus log base 3 of x plus log base 3 of y. That's it. I've just split them up. Not too bad. Log of 3 over x. The base is not specified, so it must be 10. I can continue forward writing base 10, but I don't have to, so I won't. So this is going to be log 3 minus log x. Division turns out as subtraction. Natural log of 5x over yz. Same story, it's written as natural log currently. I could rewrite it as log base e, but there's really no reason to, so I'm going to leave it as natural log. So, let's look at the numerator first. So it would be natural log 5 times x, so this would be plus natural log x. And how do I want to say this?
And then you minus natural log y.
Sure, yeah, minus natural log y, we're dividing by y, but is this going to be minus or plus z?
I mean, I thought it would be, well, it's plus z because it's like, it's multiplication.
This is ln, Graham. Does that make sense,
It's
Graham?
basically number 1, but you have a subtraction to that.
Natural log means, ln means natural log, so natural log x is equivalent to log base e of x, the number e. We haven't talked much about the number e, but it's kind of like pi. It's like another transcendental constant. So, if you look at this, it's 5x divided by yz. So it would be like 5x minus the product of yz. So this would be ln y plus ln z. Do you see why this would have parentheses? Does that make sense, y'all? But the way I really like to think about this is ln 5 plus ln x divided by y, so minus ln y. And notice, if you have what do I want to do? If you have 12 thirds divided by 2, this becomes 12 divided by 3 times 2, right? So this is the same thing as minus ln z. In other words, see, I just distributed this. So the way I really like to think about this is everything in the numerator as multiplication ends up positive, and everything in the denominator as division ends up negative. Does that make sense? Any questions on this one? Because this one's actually pretty difficult. So anything in the numerator ends up positive, and anything in the denominator ends up negative.
So the denominator is a negative Nancy.
Precisely. Give me 1 second, y'all. Alright, so let's try another one. Log base 2 of 3 to the 11th. I'm running out of room. So sad. Okay, let's see. This is going to be that third rule. Exponentiation comes out front as multiplication, so this becomes 11 logs base 2 of 3. And then I'll go ahead, yeah, this looks good. 5x squared over y cubed. Okay, so there are a couple ways to think about this. I'm going to do this the long way right now. So it would be log base 5, log base 7 of 5, plus, because it's times, log base 7 of x squared. This 2 is going to come out front eventually. I could have already done that, but I'm going to leave it like that for now. And then this is on the bottom, y cubed. So this will be minus log base 7 of y cubed. Same story. I could have already thrown this 3 out front, but I just want to be super clear with what's going on. So here I got log base 7 of 5 plus 2 log base 7 of x minus 3 log base 7 of y. Same story. Everything in the numerator ended up positive. Everything in the denominator ended up negative. Whoops. Okay. I'm going to give you guys a couple practice problems here. Let's see. Need more space, so I'll scroll up. Log base 2 of 13y over 5. Log base 4 of pi x squared divide by y cubed. So the pi and the x squared are both in the numerator. It doesn't really matter. It would be the same either way. And then lastly, log of 3z squared over 7 squared. I guess I'll do let's do x w to the 5th. There you go. Okay, attempt these 3 and we'll go over them. Please let me know when you finish so I know when we can go over it.
two's okay. They're all basically like the same thing as that one example, like back there where you had like the log n in parentheses 5x over yz, right?
Yeah. hmm Yeah, so pi x squared is the numerator and y cubed is the denominator. Has anybody finished? Thanks, Robert. Does anybody need more time? Alright, I guess let's take a look. So this becomes, number 1 becomes log base 2 of 13 plus log base 2 of y minus log base 2 of 5. Number 2 becomes log base 4 of pi plus 2 log base 4 of x minus 3 log base 4 of y. And lastly, we get log 3 is base 10, right? Plus 2 log z minus log x minus 5 log w. Everything on the denominator turns out negative, so the log x and the log w better both be a negative. Any questions on these three?
Do you want to put the one on number 3 in parentheses near the end, like last two expressions, like on last problem?
You mean, can you write it like that?
Yeah, because I thought on last problem you
Yeah,
wanted
I did that too.
on parentheses, right?
This is correct. There's nothing wrong with that. But imagine if you were to distribute this negative sign, then it turns out as that, right? So I've just gone ahead and done that. You can write it this way. That's perfectly fine by me. I just don't like to. But you can. I don't mind. It's correct.
Okay.
Sweet. And let's take a gander at the next variety. So just going backwards instead of expanding, but to compress. So the idea is to express as a single log so we have 1/2 log base 3 of 7 minus 6 log base 3 of x plus 5 log base 3 of m. One second, y'all. Cool. Okay, so just like everything in the numerator turns out positive, that means everything that is positive goes back into the numerator, and then everything that's negative goes back into the denominator. And there's no parentheses, so I don't have to worry about anything like that. So here I get log base 3 of 7 to the 1/2 power times m to the 5th power divided by x to the 6th power. Any questions here?
Okay, wait, why is the subtraction sign like between the 7 and the 6? You know what I'm talking about? Like, wouldn't you add them since you're like multiplying?
Subtraction means division, right?
Oh, okay. I
So,
forgot.
so here's that division, if that makes sense.
Okay. So you don't like do the 7 and then plus the m and then subtract the like x to the 6?
Yeah, that's like it's like you do 7 times m, then divide by 6, divide by x. Does that make sense?
Okay, it's basically the same thing, I guess.
Uh-huh.
Yeah.
Yeah. And then let's see. I can even show you something else. If we did, so let's see. If we did this, okay, there we go. That's the same thing. Does that make sense? It doesn't
Yes, sir.
matter where this guy is.
Okay, yeah, that was what confused me. But
Yeah.
I got it.
Cool. Good question. Excellent question. I'll give you guys 2 practice problems on this. So same thing, log base 2, 3, 10, 15. And then 6 log x minus 4 log y. Plus 3/2 log w. Give these a crack.
I guess they have to have a common law.
Sorry, what's your question?
I guess they have to have like a common log, right?
In the first one, they're all log base 2, and in the second one, they're all log base 10. It's just not written. Does that answer your question? Yeah, we want to get it all to just one log. Just smush them all together using the rules from earlier. That addition turns into multiplication, subtraction turns into division.
Wait, but isn't that basically 3 times 10 on number 1?
What's 3 times 10?
Couldn't you just make it 30?
Yeah.
So log 30.
Uh-huh. Bingo. Y'all still working? Assume that's a yes.
I'm good.
You good? Alright, let's go ahead and go over these. So this becomes log 30 divided by 15, or log base 2 of 2, which is actually 1. So the answer to number 1 is 1. And then the answer to number 2, this would be log x to the 6th divided by y to the 4th times w to the 3/2. This is good, everyone? Do we feel comfortable with these now?
Okay, wait. So, the first one. What's the first one?
So you get log base 2 of 3 times 10 divided by 15, right?
Mm-hmm.
This turns into log base 2 of 2, and as we discussed earlier, if these numbers match, it's just 1.
Oh, I forgot about that. Okay.
Yeah, no worries. That's why I put it there.
So, Mr. Strickland, just to sum up, I don't know if you're going to go over this, but are logarithms just used to solve for an exponent?
Basically. So, if you... I don't want to say this. So, for instance... And we're gonna talk more about this as we go further, but if you have exponential growth, like a breeding population with no carrying capacity, no predators, nothing, they have all the resources they need, so it's exponential growth. If you want to find like what's the time when the population reaches some number like 200, you need logs to solve for this answer. Does that make sense?
Yes, okay.
And so interest as well, like bank interest, is exponential growth. And so log is just the inverse of an exponent. So it enables us to deal with all that stuff. And also, if you... Yeah, that's all I'll say for now. But you'll see everything about it. We have lots of time for it too. But does that answer your question for now?
Helps. Yeah, just knowing what is being written helps. Yeah.
Yeah, exactly. Okay. Worksheets on the portal. It's like slightly long, but it won't take long, I promise, because half of the problems are like these bad boys. Should take like 5 seconds each, right? Okay. So besides that, it's on the portal. Enjoy yourself. Have a nice day. The weather is amazing right now. And thank y'all.